But yeah, I'm going to present to you some recent research on carbon-aware microservice deployment. So we're in a session about carbon-aware computing, and what the last two talks had in common with actually the majority of research in this field is they were treating batch jobs. So they were treating jobs with a clear start and a clear end, and certain amount of work that we need to do. Sometimes we know the amount of work, sometimes we don't. But what we usually do in carbon-aware computing, we decide on where and when to schedule these jobs. So we have this location dimension where we can say, okay, energy is maybe a bit more cleaner in France right now than in Germany. And as well, we might have this time dimension where we can choose to maybe defer the execution of a workload until we expect energy to be cleaner. Maybe we can split the workload into parts. We can stop and resume it. We can assign more or less resources during different times, and so on and so forth. The big thing is, what about services? So a large fraction of today's compute is continuously running services. We cannot just start and stop them. We cannot just schedule them or migrate them around. So they're always running, and we define services as workloads that have little to no delay tolerance. So if you're sending a request to a website, if you're sending a request to ChatGPT, you expect a response as fast as possible. So we cannot simply wait a few hours until there's more sun or something in the grid. Now, there's, of course, also research on services. For example, the first talk that we heard in the session on carbon-aware DNS was addressing geo-distributed load balancing. And this is what all research so far in carbon awareness is doing. If it's about services, we do geo-distributed load balancing. So we decide, you have a request, and then some entity decides which server from which region is going to process your request. However, in practice, not all services can be geographically distributed. So we might have infrastructure constraints. For example, if you think of Gen AI, usually requires high-performance GPUs or other types of accelerators. They're not available at any location. Additionally, we have data constraints. So it might just be data locality. Maybe it's really expensive to migrate data. Maybe you have data regulations, so you're not allowed to move data to other jurisdictions. You have privacy, security constraints, all of this. Maybe you just have a single data center. Maybe you just don't have a distributed service and it's just running at one location. So what can we do if we don't have any delay tolerance, nor can we choose the location of our execution? The only thing that we're left to do is we can maybe adapt the quality of our service at certain times. Maybe we can reduce the quality of our service when energy is dirty, and maybe we can provide better or best service when energy is clean. Now in this talk, we're building on the sustainable application design process. So we're looking at this now from more of an information systems perspective. And the example that was provided in this paper is a flight booking platform. I'm aware that this is not a great example for a sustainability conference, but this is where we're at. This is a business process. That means we have several components. We have a flight search, weather information, flight booking, optional rental car booking, and the checkout. And what's often or usually done in these business processes, they're directly mapped to microservice architectures. That means each of these services have some constraints of how powerful a virtual machine, for example, has to be. And each of these services can independently be scaled horizontally, independently from each other. Now, the interesting thing is that not all parts in this microservice are actually, or in this business process, have the same priority. So some of these parts are simply not critical. You will still be able to book your flight without weather information. You will still be able to book your flight without a rental car booking. Now, of course, this will maybe reduce your quality of experience, and it might also reduce the revenue of the service provider, but it still works. Another example is the flight search might be available in different implementations. Maybe you have a very cheap, energy efficient implementation, which is just doing some database lookups. And maybe you also have a more sophisticated, complicated implementation that is querying a large number of service providers, and maybe you have some AI, some recommender systems, whatsoever. So you might also decide on the implementations. And this is now what the Sustainable Application Design System proposes, that application developers should have this in mind and should maybe enrich the metadata of their microservice applications that they're developing with information on the energy efficiency requirements, maybe if certain steps are remittable and all of this. And what we have been proposing, what we are working on, is a system which automatically determines hourly microservice deployments and also horizontal scale outs for microservice components based on the currently observed carbon intensity and the currently observed workload, as well as some hourly budgets. And these can be like regular carbon budgets, but if you think of renewable time-based energy certificates that are bound to a specific location and a specific time, it's quite likely that you have some hourly budgets that you need to adhere, because intraday pricing, at least on the energy market, is usually more expensive than day-ahead pricing. So this will probably also adhere to any future certificate markets. So in this research, we really just optimize for hourly deployments. I think my time is probably also almost up. I was putting focus mainly on the problem because on purpose, because our results are still quite preliminary. We tested this approach so far in one scenario in Germany on data from 2021. And we're able to achieve really good budget utilization with high quality of experience for users with very few violations. You cannot always make sure that you don't have any violations, because during some hours, maybe even the most efficient deployment of your microservice will already violate the budget, but we only had less than 2% budget violations across the year. With this, I already end the talk. So we proposed leveraging the sustainable application design process for dynamically determining microservice deployments and horizontal scale out, with the goal to reduce the carbon footprint of continuously running services that we cannot simply interrupt. As a next step, we want to also combine this, however, with geo-distributed applications. And there's some ongoing research that is really exploring the saving potential from a more theoretical perspective, as well as the practicability of this idea of carbon-aware quality adaptation over time. And there's already a preprint available on this. Yeah, open the floor for questions. Thank you.
Thank you, Philipp. And we have a couple of minutes for questions. Do we have questions for Philipp? Offline or online? I see a question in the room.
Just a clarification, this was a simulation, wasn't it? Or was it?
Yes, this is purely simulated so far.
Another question? Give me a second to bring you the microphone.
Just a note that making anything more carbon efficient doesn't reduce the overall carbon emission due to any sort of increased Jevons paradox and rebound effect. Did you try to find out if you make one aspect of it more carbon aware, if anything else is increasing? Is that something that you could figure out?
So you're referring to additional load because of worse quality of service? Because what would be the rebound effect otherwise? I don't think people use more of a service if it's worse. Unless you, of course, yeah.
It's not, people are not seeing any of this. It's the provider who are seeing this, right?
Yeah, I mean, people would experience it. So people would receive a worse quality of experience maybe at certain times for improved carbon efficiency. In the end, of course, it boils down to what your cost function is, to what your reward function is. If you're optimizing for revenue, maybe it can be cheaper to cut out some services, because then you don't have to buy more carbon certificates in the future if we have high enough carbon pricing. If you're optimizing for quality of experience, it's of course a bit more vague.